Good afternoon, everybody. Thank you for joining us for the first of our AquaSuite webinars from Royal HaskoningDHV. We'll start with a few housekeeping rules. The webinar itself, we will aim to keep it to around 60 minutes. We'll do our very best to stick to that. I'll do my best as well to make sure I don't talk too long. Everybody who's on the conference on the line itself is muted, apart from those of us who are presenting and talking. We would very much welcome questions from anybody who's participating in the webinar. The software itself has a chat/question box, so please feel free to type all your questions in that box as we go along. We have a dedicated session at the end to answer all your questions, so please type them as we go along, and then my colleagues will pick them up at the very end. If anybody can't hear me or you have issues with the presentation or video content, please also put that in the chat box, and we'll pick that up and hopefully resolve it. There will be, during the webinar, a brief survey at the end and 3 polls as part of the process as well. So we would hope everybody could fill in the poll as we go along, and we would also welcome your feedback at the end from the survey. So thank you again for joining us, and we will make a start. So good afternoon, I'm Tom Woolley, Business Development Director for AquaSuite at Royal HaskoningDHV. I've been part of the AquaSuite group for 2.5 years now. And I'm leading the process to bring AquaSuite to new markets outside of our core area, which is the Netherlands. Also taking part in this webinar at the end will be my colleague, Kim van Schagen. Kim is one of the co-founders of AquaSuite back in the mid-90s. He's also operations director for our group now as well. We also have Mahar Benashir, our marketing manager, on the call as well, and she'll be making sure everything works correctly and fielding and passing on your questions to Kim at the end. Thank you again for joining us. We will make a start. So what we want to do is start with a poll. So we actually want to understand where you are currently in terms of using automation and process control. So key for what we're going to talk about in this webinar is your ability to respond and to make use of connections and signals which can control your systems and your processes. So we'd like to have an understanding of where everybody is at the moment in terms of using automation. So Maha, if you could launch the poll, hopefully everybody will see the poll pop up on the screen. There we go, excellent. So we've got 4 choices there. So where are you now? Hopefully you have one of these options most suitable. So we've got doing everything manually, using automation itself, you've automated part of your processes, or you've already deployed artificial intelligence as part of your automation. So that will give us a really good idea of where people are in terms of currently being able to control and act on signals. So I'll just give you a minute or two for everybody to fill in that poll if you could. That'd be a really good start for us. Okay, thank you. And what we will do is come back to the results of the poll later on in the presentation, probably during the question and answers, because that'll feed in quite nicely to our next stage of the process. Thank you. So give you an idea of what we're going to cover today. So we're going to look at the introduction and the background. Partly we're going to look at why you're listening to us, AquaSuite, Royal HaskoningDHV. What do we know in terms of process control, automation and optimization? We're going to look at what is the virtual operator. So it's quite a loaded term perhaps. So we're going to look at what it is, what it can do, and then we're going to focus on some specific examples, particularly in the area of drinking water and of wastewater. So key thing for us is there's a lot of marketing talk and a lot of information about artificial intelligence, and people are giving the impression that it's the next big thing. But what we really want to do is to give some specific examples of how you can use it, where it's been used, and where it can provide benefits for you and for your customers. So starting off with who we are. So we're Royal HaskoningDHV, initially or primarily a Dutch company. We've been going for over 130 years, getting on for 140. We're around 6,000 people, 6,500 people worldwide, and we operate all over the world. So we have offices in over 50 countries. We have projects in 140 countries. We have been very much on a journey for the last 5 or 6 years to really translate what we know in terms of engineering competency, and design expertise and technical understanding into digital solutions. So we've kind of taken our expertise and knowledge and tried to marry that into digital optimization and machine learning. And AquaSuite is one of the first projects which went through this process. To give you an idea of where AquaSuite came from, what we've been doing, we first started in 1996 with AquaSuite. So people think of AI and machine learning as new. It's not new. I think the first neural networks were developed in the 1960s. The first AquaSuite application went live in 1996. We started with a very specific problem. Our client at the time for consultancy in Limburg in the Netherlands had an issue where they had 3 water sources feeding one urban area. And they had a real big difficulty in ensuring they didn't breach their consent limits for each water source. So these were boreholes. And part of the issue they had is they didn't know how much water people needed. And we started by using machine learning back in 1996 to predict the amount of water they needed for the city of Limburg. When we could predict it for them, then they could then balance the water supply from each source to ensure they didn't breach consent. Quite quickly from that, we developed into centralized control, because if we were able to predict what was needed, we were able to decide how much would come from each water source. We in turn could then balance the pumps from each water source automatically. So already back in 1998, we were live with the concept of the virtual operator, the ability to predict and control based on data and understanding from machine learning. In 2007, we moved into wastewater. It's probably, I would say, more than half of our business now within the AquaSuite group. We deployed AquaSuite as a controller for our Nereda wastewater treatment process, which is groundbreaking, was voted the most disruptive technology of the last decade by Global Water Intelligence. Every Nereda site gets controlled by AquaSuite. Rather late to the party in 2012, we moved into analytics. So you usually find that a lot of companies doing machine learning and AI start with analytics. They start by providing insights, they then move into control. We kind of went the other way. I think partly because most of my colleagues within the water part of the company were water people. So they were domain engineers, they were experts in terms of production and process control, rather than just being experts in artificial intelligence. So we started with how we could make things better. And then later on in that journey, we started to look at how we could use our algorithms to give better understanding of the networks, to give better understanding of treatment processes. In 2016, we launched our analytics project, analytics module, which can identify where and when leaks take place. And in 2018, very late, we actually commercialized AquaSuite into a standalone team. So in 2018, we bought a data science company, Informed, which gave us much greater capability and resources in terms of what we could do for artificial intelligence. And we also formed AquaSuite in 2018, which is when I joined. My colleague Kim, who's also on the call, has been with us since the very start. So where are we? Why are you listening to us? So this is again from GWI. This is a graphic they produced. They've put into place a number of companies. Some of you might be on the line from these companies, and they've created this space you can see at the top left-hand corner there. And they think, and we think, that we fit in this point. So we don't do hardware. We will never do hardware. What we do is make use of data for automation and control and for insights. So we don't do sensors, we don't do process PLCs, we don't do any of that. What we do is take data and make it useful. And that's what we've been doing for the last 25 years within AquaSuite. We've been actually taking data from anywhere, and we can take data from SCADA, we can take it from IoT sensors, we can take data from PLCs, and we then turn that into useful information. And in turn, the virtual operator concept takes that useful information and starts to control processes better. I'll give you an idea of who we're working with. So this is just a small section, primarily Dutch, but we've grown quite quickly into markets in Southeast Asia, in other parts of Europe, and into North America. So why the virtual operator? So drinking water and wastewater networks, infrastructure, above ground treatment processes, they're all getting more complex. They're all becoming more and more difficult to visualize and to understand. and they're also very vulnerable to changing conditions. So we live in a situation now, COVID-19 is a very good example. People's consumption of water, people's production of wastewater has changed massively. So we're starting to see different patterns of drinking water consumption. We're starting to see an awful lot of blockages within our sewers because of people using alternatives to toilet paper at the moment. This becomes more and more difficult to manage. And if you couple in the effects of climate change, such as drier summers, often shorter, sharper, more intense rainfall events, all of this process, all of this change becomes more and more difficult to manage and to understand. Coupled to that, it's becoming more and more difficult to get skilled operators. So I mean, I visited a treatment works not long ago, and there was a guy in that treatment works who'd been working there for over 30 years. And he knew everything about that treatment works. His knowledge, his understanding was fantastic. What we don't see now is people coming into the water utility market and people into those type of roles who are willing to spend 30 years on the same wastewater treatment works. People like variety. The younger generation are starting to crave the ability to move from role to role and use those transferable skills, which is great. But what it does mean is that your skilled operators are people who are willing to be there 24/7 out, working nights, working days, working weekends, are more and more difficult to find. Particularly now, again, we're seeing that a lot of people, I heard statistics the other day saying that a quarter of the workforce for some utilities in the UK are self-isolating in the UK, self-isolating at home. It becomes more and more difficult to ensure you've got resilient operations with these conditions and with this changing workforce. We see research saying that over 50% of water professionals will retire in the next 3 to 5 years. It's becoming more and more of a challenge to make those people you've got now who are operating your processes really, really well, ensure continuity of those people into the next generation. So 5 years time, 10 years time, where are we? How do we ensure that all the good things that are happening now are also happening in the future, plus additional benefits from data and for IoT sensors and so on? So you've got all this data, you've got more and more data. People talk about IoT and the fourth industrial revolution, all these other concepts. Water utilities have got masses of data. They've got data going back 20, 25 years, and some really, really, really good data. The difficulty often is that data is siloed. So you have data over here, which sits with the wastewater networks people. You've got wastewater treatment, you've got drinking water networks, you might have leakage departments. You've got all these other different parts of water utilities. There's a real need to bring this data together. So if you know when people are using drinking water, that in turn helps you understand better when your treatment will be required for wastewater. So how can you bring all these solutions together? How can you make the best use of all these new sensors people are putting out? And how can you adopt that technology to help you preserve the knowledge we've talked about when your operators reach retirement or when your operators become more difficult to find? How can you do that? And what we see is the concept that I think we coined however many years ago of that virtual operator, that solution, that software package, which can bring together the domain knowledge from the operators, the software expertise from the developers, the AI understanding from the data scientists. You've got that software. It can build up those rapid connections. It can start to make predictions of what's going to happen, and it can help you anticipate changes. So you can see that consumption's changing. You can see that the levels in sewers are starting to change. You can see that your treatment process is becoming more unstable. If you've got that virtual operator, that whole concept of somebody or something being able to predict what's going to happen, anticipate when things will change, and give better insights to operate the network, but also be able to automatically react to those changes, that will give you a massive step change in resilience, performance, and efficiency. Within the AquaSuite team, most of us are water people, so we're very passionate, and we believe that data-driven solutions can move and can help people get to that really resilient, reliable, efficient infrastructure. And that's the goal that we have, is to help water utilities move along this journey to ensure everything stays exactly as it is now, as good as it is currently performing, but with added efficiencies and with added resilience. And that's what we think the concept of the virtual operator is. So it's the ability to foresee what's going to happen and make your desired outcomes happen. And we break it down into 4 different parts. We call it smart optimized control. The first one is analyze. It's bringing together all that data from all those silos we talked about, from wastewater treatment, drinking water treatment, DMA flow meters, wastewater level sensors, all of that stuff. Bring it all together, analyze what's going on, and in turn use that to predict what will happen. And that's the big, or one of the big benefits you get from automated optimized control using machine learning as opposed to feedback systems. It gives you an understanding of what will happen. If you have an understanding of what will happen, when people will use water, when they will flush their toilets, you can in turn start to look at when things don't happen as they should do, in case of a leak or a pollution incident, or you can use that prediction to start to control your processes better. So you get this learning, you get this better understanding of the process and what's going on, and in turn you can use that to optimize and control your processes better. So that's the aim of the virtual operator as we see it, is being able to pull together all of that data. And don't get me wrong, your human operators can do that too. Your human operators are very able to bring together all that different data sources, but you need an awful lot of them. And you also need them to be there 24 hours a day, 7 days a week, 365 days a year. And what the virtual operator does, it takes those repetitive tasks, that ability to spot differences, predict what's going to happen from humans, puts it into the software and enables you to get the benefits of your best operator 24 hours a day. And that kind of leads us into our second poll, which hopefully Maha will launch for you in a second. What is your key reasons for using the virtual operator? So why do you think you could use the virtual operator? What are the benefits you'll get? And we've got 5 answers there for you to choose. The first one is to unburden operators. So take away all of these boring, repetitive tasks from operators. Second one is to improve the processes in an effective and efficient way. The third one is to help you make better, well-considered decisions. The fourth one is to help you reduce expenditure. And the fifth one is to help you preserve valuable knowledge of your operators. So what we're trying to do here is just get an understanding of what you're trying to do and how you're trying to get benefit, or how you might get benefit from using a virtual operator. So I'll just give everybody a few seconds to put their inputs into that section. Okay, hopefully everybody's had a chance to vote and we can then continue with the presentation, please, Maha. Okay, we're back live again. So what we're going to do now is actually look at some examples of partly where we've used the virtual operator concept within our platform, but we don't want to make this as a sales pitch. What I'm going to do is hopefully just look at some examples where we think water and wastewater utilities benefit from the virtual operator. And the key thing we're looking at is, where can a virtual operator help you improve efficiency, help you improve performance, and provide resilience and reliability? The first one for drinking water, we've tried to summarize the mission for drinking water, and we think it kind of boils down to ensuring resilient, efficient water supply for everybody. And in the Western world, that's kind of, I think most countries in Western Europe and North America have achieved that. But we do see there's benefits in terms of reducing water availability, even in developed countries like the UK, but also for the developing countries where water isn't as plentiful as it could be. And how can the virtual operator help those developing countries make as much use of the water they have available as possible? So the first one we're going to look at feeds into that one in terms of production. Here's a rather simplified image of a resilient water supply grid. So you've got 3 municipalities or 3 urban areas, and they're being fed from a multiple, in this case, 3 sources of water. So it's fairly simple. So it's a subsection of one of our networks in the Netherlands. And the challenge here is, you've got these 3 sources, you've got these 3 urban areas, you've got the different reservoirs within that system. How can you ensure that everybody gets water at the best possible quality and most efficiently? And if we have that concept of the virtual operator, and that virtual operator is able to predict the demand for each one of those urban areas, and in turn it can decide which source is best suited to feed the area in terms of efficiency. So you don't want to pump water too far away. In terms of water quality, you might find that some sources are softer than other sources. How can you blend all that water together? And the virtual operator is able to take all that information, much like a human operator, take all of that information, use that prediction to decide when you're going to pump water and where from. And if you can do that, if you can use that methodology, and this is exactly how we started with AquaSuite back in the 1990s, predicting water demand, and then use the artificial intelligence to decide how that demand is met. The secondary benefit you get is if you have this real-time optimization solution, the virtual operator can also react when things don't happen as they should do. So if a pumping station fails or a reservoir, service reservoir goes out of use, the system can start to dynamically reroute water to ensure your customers still get a water supply. And that's key. So everyone's mission is to supply that water. The virtual operator can help you supply that water first efficiently, but also in the case of emergencies. And it can also provide that ability to react quickly to these problems. So it can flag up and send out priority alerts to the operators to say, actually, you need to go and look at that pumping station, or you need to go immediately out to this area because there's a problem in this part of the network. It's exactly the same thing as a human can do, but it's just making it quicker, smarter, and hopefully more efficient. Second example, and this is something a lot of companies have looked at over the years, reservoirs. So service reservoirs, they're great. Operations people love them, but they also love keeping them as full as possible. I was on a call a couple of days ago with a water utility, and they said that their operations colleagues would love to keep every single reservoir at 100% full or overflowing all the time, because it gives them that confidence. They know if that reservoir's full, no one's going to complain to them. No one's going to tell them there's an issue or there's a problem. They've done their job. They've got as much water in the network as possible. But if you do that, if you keep your reservoir levels as full as possible, that causes problems in other parts of the system. It means your pumps are going to be switching on and off. It means your water age within that reservoir, if you have chlorinated water supply, becomes a problem. And the reason that we think the virtual operator fits really nicely here is just in this trend you can see on your screen at the moment. The green line, the green dotted line, is prediction of outflow from that reservoir. The green solid line, which is hopefully very close together, is the measured data, it's the actual data. So the virtual operator is really able to show that what's going to happen, the predicted line, is very, very close to the measured line. And if you're able to give the operations or the operators or the people looking after the water supply that confidence to say, your predicted data is so close to your actual data, then hopefully they'll be willing to let you do what we do in this case, which is let that reservoir level flex. So the blue line at the top, the dark blue line, is predicted reservoir level versus actual reservoir level. And again, hopefully you can see they're really close together. Because the operators of this system are confident in what's coming out of the reservoir, they're willing to let that level get down to, I think in this case, around 40%. And that's really unusual. That's something which doesn't happen very often. There's loads of benefits to this. One of the big benefits you can see is the red line in this image. That's the flow into the reservoir. Now, normally that flow would be very steppy. It would be on, off, on, off. And that in turn creates problems upstream in the network because it causes pressure transients. It's also less efficient for pumping. If you can run your pump at a constant, efficient speed, then it's better for energy usage, it's better for your network, and it's better for water quality. And all of that benefit flows from having the certainty of prediction, having that ability to know exactly what's going to come out of your reservoir at any time. You then get that ability, that confidence, you can let your reservoir flex and let it go down to 40%, let your water recharge, which is better for water aging, and also better for your network as well. Third example, which is unfortunately a rather complicated image, is pressure control. So this is one area which we are starting to see more and more interested in. There's lots of companies doing pressure control in terms of reducing the final distribution pressure using pressure relief valves, pressure reducing valves. Some companies are doing advanced pressure control, so they're changing the pressure of those valves according to demand. Some are doing feedback control, where they're looking at the critical point pressure and feeding back and changing it. All of this aids to reducing leakage, improving customer service and supply, but it becomes more and more complex. You start to find that if you really try and get your pressure as low as possible whilst meeting demand, your critical point can move. So what is your critical point in the daytime might not necessarily be your critical point in the afternoon. And that's what this example here is. So we've actually got 9 different points within the network, which can be the critical point at any particular time in the day. So again, it's something a human operator could do, but I suspect it might become quite complicated quite quickly. If you can have the virtual operator, the AI solution, predicting the pressure for every single critical point, dynamically changing which one becomes the controlling point, and also providing predictive feed-forward control rather than feedback control, you can get to the situation here, which we've got in this image, where the lowest possible average system pressure is maintained. And that really helps in situations where you've got background leakage, you've got potential problems around meeting supply or meeting demand. And the virtual operator really fits really nicely with these sort of really complex situations where you've got multiple feeds, you might have multiple critical points, and it can really start to make it as efficient as possible while still ensuring everybody gets enough water. So what does all this mean for you in terms of optimization? You get a more resilient network. Don't want to gloss over that because that's a really important point. So giving that resilience in terms of continuity, if your operators are not available or they're potentially reaching the end of their working lives, you get lower operational costs. So we've seen some really good benefits. Our largest customer on average saves around 7 or 8% energy using AquaSuite for drinking water. Doesn't sound much, but that's while still maintaining that resilient network. And that's averaged over the past, I think, 10 years. And you can reduce leakage. If you can reduce the pressure in the network, it's quite clear that you can reduce leakage and potentially the number of bursts you might get within your network as well. That kind of leads us on to the next bit. And this is a solution where we're using the virtual operator to provide insights rather than to control the network. I'm not going to talk about this one in too much detail because we're actually going to host a webinar later on, which is going to look specifically at leakage and non-revenue water. But just give you a very quick whistle-stop tour of how you can use the virtual operator to find leaks. The image on the left-hand side you can see here is quite small, so hopefully everybody can see it okay. But it's comparing predicted flow rate with actual flow rate. And what you can see on the latter part of that trend is a big jump in measured data. And that's exactly what happens when you have a leak. And this was a real leak from one of our customers, our clients. The leak happened. AquaSuite, the virtual operator, told them about that leak. They were able to get out, find it, and fix it all within 6 hours. And that's really impressive. The average runtime for leaks in, I think, the Western world can be 10, 11, 12 days. I certainly know of examples where quite considerable leaks have run for months, if not years. So if you've got that ability for the virtual operator to tell you there's a leak, you can get out there, you can find it, and you can fix it. And that has multiple benefits. First off, it means that your water loss is less, which is great. It means you're saving energy. It means you're targeting your workforce. There's loads of benefits that come from being able to find those leaks and fix them quicker. The image on the right, which I'll just touch on quickly, is where we're using a hybrid AI hydraulic model to hotspot where a leak is. And what we do is we compare simulated pressure with actual pressure to work out the most likely location for that leak. And that enables water utilities to, rather than send the leak detection crews to the whole DMA or the whole supply zone in some cases, they can start in the area where the leak is most likely. And it just cuts down that time of being able to find and fix and repair the leak. But as I say, we'll look at that in much more detail in a later webinar. And what does that mean for you? Better understanding of your network. Everybody, if you're a consumer of water, which I think we all are on this call, hates the concept of water being lost. So much better for your customers if you can say your leakage rates are 10% as regards to 20%. It's much faster, which means efficient, and it's much easier to find and fix those leaks. So we'll move on to wastewater. To a certain extent, up until maybe 5-10 years ago, wastewater was a little bit of a forgotten child for some utilities. It was something which people had to do, and they usually did it very well to the extent they could do it well. And what we've seen over the last 5 years, 10 years, is a real new focus on wastewater. So a focus on deploying more sensors in the networks, a focus on improving wastewater treatment efficiency, and within the last sort of year, 2 years, 3 years, a real focus on biosolids and recovery of useful materials from wastewater. Wastewater is not just something to be got rid of, it's actually a resource that you can use to sometimes generate money, to generate revenue. And what we try to do with the virtual operator is to make that whole process of collection, transport, treatment, and reuse as efficient and as understandable as possible. So we're going to look at networks first. So collection and transport systems. Two examples, quick examples. The one on the top you can see on the right hand side, this is genuine data from a sewer within the United Kingdom. What you've got here is a green line, and that's the level that you would expect the sewer level to be. So as everybody uses their toilets in the morning or their showers, you see a rise in the level, and then that level comes down in the daytime, it goes back up again in the evening and so on. It's a very similar pattern to what you see for drinking water, but with the added complexity of rainfall. So if you've got a combined sewer system, rainfall plus human usage is the level you would expect to see in the sewer. And what we're doing here is actually using a neural network to predict the level in the sewers, and then to draw those two red lines around the data. And that's the normal operating range. So what we're able to say to the water utility is that the level in your sewer is as expected. And then conversely, what you can do is say when that level is not what's expected. And that's an indication of either an upstream or downstream blockage. So it becomes more and more of an issue, particularly now actually in the UK. We're starting to see the real buildup of these things called fatbergs, which is an accumulation of fats, oils, greases, wet wipes, and all sorts of stuff that people put in sewers. These fatbergs cause blockages, which in turn cause sewer flooding incidents, which eventually will affect people's quality of life by either flooding their properties with sewage or damaging rivers or areas where they go for recreation purposes. So what we're trying to do here is actually enable water utilities, or we do enable water utilities, to detect these early. And if you can detect them early, you can clear them before they become a problem. So we hear of fatbergs. I think the famous one in London was the size of 3 football pitches. I mean, these are huge things which take weeks or months to clear. If you can cut them off when they first start to develop, you can improve your customer service, but you can also ensure they get removed before they become a problem. The example on the bottom is something we have particular success with. So as populations start to grow in urban areas, as you start to see more transient population, people moving for work and so on, you'll start to see that the older wastewater treatment works can become overwhelmed. So the peak flow, that flow you get sort of mid-mornings or early mornings to mid-mornings, can overwhelm treatment works, or it can be too big for particular parts of the treatment process. And if you can predict the level into the treatment works, into the final pumping station, the terminal pumping station, and you can understand the amount of rainfall that will come through, you can do something very similar to what we talked about for reservoirs and drinking water. But rather than pumping on demand, you can actually pump on what will happen. So rather than pushing that peak flow straight into the treatment works, which in turn might mean you bypass important processes, you can actually hold it back if you know that, okay, yeah, we've got a peak, but nothing else is coming. So we don't need to push that flow directly into the treatment works. We can push it through slowly. And when you can do that, you can make your treatment more efficient. You can also make maximum uses of your processes. So we have a client who has a final filtration stage, which I think was there to remove, to get them within phosphorus consent limits. And what was happening is that final stage was being overwhelmed at peak flows. And by deploying this solution, by holding back that flow and pumping it through based on what's coming in, but also what's best for treatment, we were actually able to help them reduce bypasses of that stage by 58%. There was no investment other than coupling up AquaSuite to their pumping stations and to their rainfall provider. They didn't need to build anything. They didn't need to do any more concrete. They just had to understand, or we had to understand for them, what was coming in and how we could push it out more effectively. And that's becoming more and more of an interest. So there's a big focus on carbon reduction. How can we have a no-build solution? How can we operate things without building more pumping stations, more treatment works? Which leads us on to treatment works. So everyone's talked about aeration within wastewater treatment works for years. It's a massive user of energy. Some people will say around 50% of all energy within wastewater transport and treatment. Some companies 60%. So it's a massive consumer of energy. Essentially, you're bubbling water through sewage, and that's not an easy process. So it's a big user of energy, as are the other wastewater treatment processes. So you've got filtration, you've got aeration, you've got dosing. These are all complicated and complex processes. And machine learning and AI, the virtual operator, can really start to help you operate these processes most efficiently without the need for an operator there 24/7. So we have clients who operate large treatment works, and they'll have one operator who might look after 4 or 5 treatment works, and these treatment works can cover 2 million people, 3 million people. They allow the virtual operator to take care of those repetitive day-to-day tasks, and they can then start to use their skills more efficiently in more productive tasks in terms of fine-tuning the benefit. So the virtual operator takes care of that kind of day-to-day issues of how much aeration, how much dosing, what's going on when the thing's not working correctly, and the operator is then freed up to do the more complicated tasks. Start with aeration. So everyone's focused on aeration for a long time. What we're doing here is actually predicting the influent flow and load to the treatment works. And because we've got that prediction, we can then decide how much aeration is needed based on what will happen, as regards to a lot of other systems are based on what has happened. So a feedback system will keep you within certain boundaries. A predictive feed forward system will keep you on the most efficient track permanently. And this is what we're doing here. So you can actually see 2 lines very close together. That's the set point of aeration versus the predicted set point. And hopefully what you can see is that what we're predicting to happen is exactly what is happening. And that means that we can understand the efficiency of the process. Every aerator is different in terms of efficiency. So we use machine learning to understand what's the most efficient set point. We then decide which set point we should use based on the predicted influent flow and load. And that can save you 10, 15, 20% energy, if not more. The key thing is, though, we're saving that energy while still ensuring your effluent is compliant. So we're making sure your effluent meets all your regulations. It's stable, which is important. So different countries have different ways of testing effluent. This type of 24/7 virtual operator will keep you on a stable effluent situation, rather than you having peaks and troughs depending on who's operating your systems. And the same goes for dosing as well. So the amount that you dose, we will decide set points based on prediction of influent flow and load. We'll work out what's the most efficient dosing point and ensure that you don't overdose or underdose. So you maintain the constant or the most efficient amount of dosing within your processes. That brings us on to the last area we want to look at, which is the virtual operator for sludge processing, or biosolids as we're supposed to call it now. This is a real growing area. This is the start of well, it's already started, a new industry. How can you recover as much useful material from your sludge as possible? There's been, over the last probably 10 years, maybe a little bit longer, a real focus on what you can see in this image, which is digestion, so recovery of biogas from sludge. But there's also now starting to be a movement to look at recovering other materials, such as phosphorus. We've got a limited supply of phosphorus in the world. Let's not burn it. Let's not put it into landfill. Let's try and get as much of it back as possible. And we see this particular area of sludge processing as being really beneficial from artificial intelligence, the virtual operator, because it's so complex. As an example, here is a deployment we've done in the Netherlands, where we've got an internal sludge line and we've got multiple external sludge lines. So we're starting to see this trend towards very large sludge treatment centers or very large recycling centers. And what tends to happen is you might have, I think one utility in the UK has 2 sludge treatment centers, and it has over 600 wastewater treatment works. So all of that sludge from those smaller works comes into your big works, where it gets processed and it gets digested, and they extract the biogas and they extract what other material they can extract. But becomes really complex in terms of managing the internal sludge line from the works itself, plus all of these external points. And artificial intelligence, machine learning, the virtual operator can really help you play a tune here. So it can start to say, right, we know these external treatment works, we know the levels in the buffers right now. We can predict what the level will be tomorrow, the next day, and we can start to schedule the movement of the collection lorries, the tankers, to ensure first that they're emptied when they need to be emptied, but also they're not emptied too often. And you can actually start to really manage the flow into the digesters to ensure constant flow into your digestion, which in turn helps you maximize your biogas yield. So if you can do that, if you can manage the flow in from your internal line and all of your external buffers and make it as constant as possible into your digesters, you can really start to get maximum yield for your digestion. And the second part of that, it kind of links to the first part. Sludge is wet. So you don't want to be tankering water around. You don't want to be putting wet sludge into incineration. You don't want to be spraying wet sludge onto land or too wet sludge onto land. You can use machine learning, if you can use the virtual operator, to understand how efficient your dewatering is, your centrifuges or your belt presses. You can start to learn how much polyelectrolyte you need to add to get the most efficient dewatering processes. So your machine learning, your virtual operator can be continually tweaking this process you can see on the screen here. It can be continually deciding, okay, this is what's coming in. This is how much dosing we need based on that prediction. This is the set point for your centrifuge to ensure driest possible sludge out, but also minimum usage of energy and polyelectrolyte because they're expensive. And that's the aim of not only the sludge line, but the whole process. It's ensuring you can meet your requirements to provide water, to treat water, to move biosolids as efficiently, as effectively, and as insightful as possible. And that's what we're trying to do across the wastewater. So we're giving you better understanding of your networks, trying to help you reduce spills, flooding, help you pump more efficiently, help you operate your treatment works more efficiently. The virtual operator is always watching. It's always reacting. It's always changing. He's always, or he or she, not sure. They are always there. They're always keeping an eye on your treatment works. They're always making sure they're operating as best as they can. And they can help you maximize your biogas production and lower operational expenditure. It's a nice quote from one of our clients. They're using the virtual operator on treatment works and on pumping stations, and they've been able to make maximum use of their assets and ensuring stable effluent quality, which is most important. That's kind of where we are. So what we think is the virtual operator is there to augment your operators, to help your operations team continue the good work they've been doing, but with the ability to understand what's going to happen in terms of prediction and also react as quickly as possible to when things don't happen as they should do. And that leads us on to our final poll, which is, what area do you think would gain the most from the virtual operator? And hopefully if Maha can launch the poll for us. So we've got 5 areas: drinking water production, distribution, drinking water network intelligence, wastewater collection and transport, wastewater treatment, or sludge processing. Which of these areas do you think is going to benefit the most from using a virtual operator? So which of these areas will get maximum benefit from a solution such as AquaSuite or such as an artificial intelligence, machine learning, optimization, or analytics solution? I'll just give you a few seconds to vote there. Okay, thank you. If we could come back to the presentation, Maha. There we go. So this leads us on to the final section, which is question and answers, with Maha introducing the questions and Kim, our resident expert and veteran of AquaSuite, fielding the answers for you.
Okay, I have the question 1 sent to me by Maha. I will read it aloud. So can you give me a recent example of how the virtual operator has contributed to drinking water supply? As Tom introduced to us, in the drinking water supply, we're already active for a long time. but a good example of having improvement in the recent time is that in one of our areas there was a leakage at night, and it was signaled right away. And not only it was signaled, but right away also it was taken into account in the prediction of the drinking water supply. So the production was already raised at the site before the drinking water reservoir was empty. So because it already detected that this leakage was taking place. So it was solved on both sides. So in the distribution network, the leakage was found quickly, but already the production was increased. Not too big, only slightly, only compensating for the leakage, and that meant that thereby we didn't have big variation in water quality. It was. Is that helping? An answer good enough for you, Maha?
Yes. Can you hear me now?
Yes, I can hear you now.
Oh, great. Sorry, guys. I had like a little bit of difficulties. Thanks for the answer, Kim. So we have another question, which is, do you have a solution for monitoring small RO plants, monitor the plants, and act as a virtual operator to prevent problems in the plants?
Yeah. So where the virtual operator sits is not how you say it. It's not important if the plant is small or big. On a small plant, of course, you don't want to sit the operator on site or have a big investment on site because it's a relatively small plant. So if we have multiple smaller plants, then we tend to take that clever software away from the plant, but to a centralized cloud solution with only a good or a connection to site. So our virtual operator is not only made for sitting on a plant with continuous communication, but also is made in such a way that also if the data transfer is remotely, it transfers that data remotely and then does the calculations from a cloud or from a private cloud, just depending on what a board wants, and sends advices back. And that can be in two ways. So some plants we send only like day pattern advices, so we only have to communicate once a day. And for other plants, we send a advice more often. And by that, you have to take into account that, of course, the local automation system is always taking care for safety and for robustness of the installation. So it takes up the advices if everything is communicating fine. So also for smaller plants, of course, we will not install a lot of things locally, but we will make a cloud or a private cloud solution.
All right, thanks, Tom. I have a question for you, Tom, from the US. Do you have any customers in the US using the virtual operator for sludge and wastewater operations?
We do have for wastewater operations. I think we have 2 live to date, not on sludge yet. So our sludge module, AquaSuite Mine as we call it, is very new to the market. We deployed it first time, I think it was, Kim probably would know better, I think it was probably October last year, was it, Kim? September, October?
Yeah, somewhere there, yeah.
Yeah, and we're seeing some really good benefits. So we've seen around 3 or 4% improvement in dewatering processes, but we've not taken it to the North American market yet, but we really would like to. So we do see AquaSuite Mine as being a real area of interest. In particular, it's a patented solution as well. So hopefully it'll grow worldwide as the sludge market grows as well.
All right, thanks, Tom. Another question for you, Kim. How does the AquaSuite system connect to the SCADA system? And can you talk about data security?
Yeah, sure. So of course, to start with the most important part, data security, all of our solutions is really aimed for to get to keep a close communication between plant and virtual operator. You don't want any intrusion outside, or so the first the first step we always take is to make sure that all communication is safe and that there's in fact intrinsic security, so there's no way to hack your way into that communication. We always connect in a layered manner, so we never go directly to a pump or directly to a valve. There's always a layered infrastructure where you say you have your basic layer of local automation and local PLCs connecting to the installation, and on top of that, then there your local SCADA, and next to that we normally set a small, what we call a communication provider, so a small piece which connects to your SCADA locally in a safe way, and then in a safe way makes connect to the virtual operator. So the virtual operator is not intruding into your plant. In fact, your plant is reaching out to the virtual operator, sends him data and gets responses back. And in that way, you always are sure that you're not opening your front door for somebody else getting into your plant. So that's the way how we set it up. The way in detail how you set it up, if that's OPC or OPC UA or other kind of communication, that's always very client specific, because it should fit in the IT infrastructure of the specific installation location. We don't want to have extra burden for the IT people or the IT department from the client. It should be seamlessly be connected with them, because it's their infrastructure and they must be 100% sure that they can manage it, and that's clear. But that's the principal concept is a local installation reaching out to the virtual operator, sending over data, getting the answer back, and implementing it locally.
Thanks, Kim. Another question from India. Do you have any tie-up with anyone in India?
I think that's one.
That's a question for you, for Tom.
Yes, we do have a partner in India. I'm happy to answer that one offline later on. But yeah, we actually do have a number of projects live on drinking water in India. We're keen to move more into the wastewater market as well. So if you could mark that question, I'll come back to that one separately later on. Wow.
All right, thanks, Tom. Another question. How does the virtual operator capture knowledge from experienced operators? Question for you, Kim.
Yeah, so we believe that that's the human capability. So we don't think we want to install like a magical box where you just out of data some virtual operator emerges. For all projects we do, we talk to the client, talk to people in the field, and we make, I could say, the framework of this virtual operator. So the virtual operator, like a normal operator does, has a lot of knowledge inside, and it gets it from all kinds of sources as a background, so as a framework. And what it then does, using the data which you get locally from your SCADA, but sometimes also getting data in from lab samples, you can then determine how the framework should be moved, what actions should be moved. So we always have a combination of field knowledge or the water science knowledge on one hand, giving the structure of the problem, and the other hand, getting data from the real installation to adapt that structure to the actual situation. And that adaptation is a continuous process. It's not a one-time adaptation, it's a continuous process. But your framework stays the same. And so you know that if water flows into a buffer, the level rises, and when it flows out, the level goes down. We don't have to detect that from the water flow measurements. We know that from beforehand. We put that in the model. But how quick it goes up and how quick it goes down, that of course depends on clogging or on sizes of reservoirs, and that's the things we can then use data to detect. So that's our principal structure, and so we really use of human knowledge in that sense. And of course, moving from one side to the other side, this virtual operator for wastewater, virtual operator for gets cleverer and cleverer, because it takes knowledge from the other plants over to the next plant and to the next plant.
Thank you, Kim. All right, so we have time for one more question. So you spoke about the virtual operator for wastewater. Does that also include industrial wastewater? And can you give an example of how the virtual operator works for the industry, if that's the case?
Yeah, so yes, sure. So it's not only wastewater. Our common household wastewater is of course where we started a couple of years ago. But also for industrial wastewater, we use that. Of course, the contradiction to household water, the amount of water coming in from industry is of course much more variable, and the loading is of course much more variable. But even in that case, you can learn a lot from historical processes taking place the day before and the day before that. So again, here we use the same. So we use less influent flow prediction because you have it's less predictable in the industry. But I mean, you know that especially in one plant that during the week there's works, and in the weekends always stops, and on Friday it's always clean. So that's our patterns that are in, which you can use in using the virtual operator to know when to do what. So yes, we do also industrial plants virtual operator.
All right, thanks. Yeah, I think we answered all questions. So Kim and Tom, if there is anything else that you'd like to mention, I think now's the time before we close.
No, I'd just like to say thank you everybody for listening. We had some really great questions. Hopefully everyone on the call's got a lot of benefit from what we've been talking about, and we would very much welcome any feedback, both within the survey or if you'd like to talk to us directly using the information on the screen. Thank you all for your time.
Thanks, and until next time.